All right, we're recording now for 6.1, Introduction to Ratios and Rates, found on page 449. This is the pre-algebra text for CAP045, Introduction to Ratio and Rates. And it goes through a couple of definitions. Ratio is just a comparison, a quotient of two quantities with the same physical units. So like 3 is to 4. And we would read this, the ratio of 3 to 4, or 3 to 4, or 3 is to 4. We could see it as a fraction with a fraction bar. You could see it as a backslash. You could also see it with a colon. But most often in math, we have it look like a fraction, because that's what a ratio is, and what fractions are. They're just a comparison of two parts, of two things. All right. When they are just in fractional form, you always want to make sure you simplify them. So like in example 1, it says express the ratio of 36 to 24. So you write 36 over 24. Always write your first number in the numerator position. And then you would want to simplify that. So we know we could divide both of these by 12, and we would get it down to 3 to 2. So that's the same ratio at 3 to 2. And then you just leave it like that. Don't change it to a mixed number, because now it's a ratio. It's saying there's 3 parts to every 2 parts. All right, so you'll practice simplifying your ratios. Also, you might see decimals like 0.12 to 0.18. This is on page 450. So just write it as a fraction, 0.12 over 0.18. The first thing you're going to need to do is build these up so that they're whole numbers, so that you can simplify them. So you did this in division land, where you moved your decimal. So you take it and you move your decimal over twice on both of them, and it's actually 12 to 18 is a same ratio, because we multiplied both by 100, didn't we? So 12 to 18 could then be reduced by dividing both of them by 6, and it's actually a 2 to 3 ratio. So like 12 cents to 18 cents is the same as 2 cents to 3 cents, right? So decimals can also be simplified by just building them up to their whole numbers and then simplifying them. If you build up one by 100, you got to build up the other by 100. So be aware of that. If you need to build up one 3 places, you got to build up the other 3 places. Remember, if you move the decimal twice on one of them, you got to move the decimal twice on the other. Always move them the same number of times to keep it equivalent, right? And then they show like a rectangle in example 2 on page 450 that has a 2.5 inch or 2.5 foot, width, and a 3.25 foot length. That can be a ratio. You can show that as 2.5 feet over 3.25 feet. We can cancel our feet, and then change both of these to impropers. So we have, actually I did this a little backwards. Sorry, your book decided to compare the length to the width. So let's make sure we follow that. So we have 3.25 compared to 2.25, 2.5. I'm not talking very well today. All right, 3.25 over 2.5. Change that to improper fractions. 4 times 3 plus 1 would be 13 over 4, all over. 2 times 2 plus 1 is 5 over 2. That's just a complex fraction. Don't worry about this. So know that this just means division, doesn't it? So it means 13 over 4 divided by 5 over 2. You know what to do that with that in fraction line. You're going to flip and multiply, right? So you're going to flip your second fraction and change to multiplication. So you actually have 13 over 4 times 2 over 5. You can do some simplification, and you end up with 13 over 10 is your ratio, and you can just leave it that way. 13 is to 10, okay? So when you have a fraction compared to a fraction, change them to impropers. Remember that the big, ratio bar, fraction bar is just division, so rewrite it as division. Use your fraction division principles, flip the second fraction, change it to multiplication, and then use your multiplication skills with fractions and multiply, and then leave it as 13 is to 10, because we want to say that's the ratio, 13 parts to 10 parts. So it's okay to leave it as an improper as long as it's simplified. The next section talks about rates, and a rate is when we measure things that are different. So we compare two different things, like miles to gallons would be two different units. And the first example is comparing just that. It's saying 224 miles to 12 gallons. So you can simplify this and get it down to a simpler rate. You could divide both of them by 4, and we would get it down to 56 miles per 3 gallons. And you can just leave it at that for now. It's just the most simplified version of 224 miles to 12 gallons, means it's 56 miles to 3 gallons. And notice the units are left next to the numbers because they're different, and this would be a rate. So leave your units. Don't say it's 56 to 3 because we're like 56 what to 3 what. We don't understand. Then we go a step further and we can make unit rates, and this is very popular really in real life. We talk in unit rates all the time, like dollars per hour, miles per gallon, miles per hour, gallons per minute. So on page 452, a unit rate just means that the denominator is 1. It's per 1. So what you're going to do is just do the division. So example 4 says 120 miles per 4 hours. Okay, we're going to just do the division. 120 divided by 4, that's 30. So we answer it as 30 miles per 1 hour. So you just do the division and then answer it as per 1, whatever it is, miles per hour, dollars per hour, that kind of thing. So example 5 talks about that, very popular work problem. If the person worked 8.5 hours and received $95 for their efforts, what is the hourly rate? So you would take $95 over 8.5 hours. Well, that just means $95 divided by 8.5 hours. So you take 95 and divide it by 8.5. Your book does the long division, but I'm okay with you using your calculators now to be good problem solvers and more efficient. So we would have 95 divided by, and because it's money, we're going to want to round it to the nearest penny. So it'd be $11.18 per hour, right? And we could write per hour like that, or you could write it as a ratio, $11.18 over 1 hour. Not ratio, rate, excuse me, because it's two different units. All right. Do the same thing on page 453 for miles per gallon. The problem says there's 42 miles per 15 gallons. So you're just going to do the division. You're going to say 422 divided by 15. And again, you can utilize your calculator.
422 divided by 28.1333.
So we're going to round that to 28.13 miles per gallon. You could say miles per gallon. You could say mpg. Oftentimes we use that as a unit indicator. Or you could write 28.13 miles all over 1 gallon as a rate. Right? And then they go on to have you in that problem solve another one and then compare so you can decide who has a better miles per gallon rate. So that is the unit on 6.1, ratios and rates. 6.1, ratios and rates. It's mostly about learning how to write them and simplify them and then do the division to make them into a unit rate. Pretty basic math. You've been doing simplification since fractions, so now you just do that again, but just keep it as a ratio in that ratio format. Don't change it to a mixed number. We want to be able to know what we're comparing. And also with the rates, just do the division And certainly you can utilize your calculator to help speed that process up. Just double check your answers so that you're putting in the right values in your calculator. And that is the end of 6.1. We'll move on to 6.2, proportions, ratios and proportions, I believe is the next section, an introduction to proportions. So we'll see you in the next video.